आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. Question says that let R vector be a non-zero vector which satisfies R dot A vector is equals to R dot B is equals to R dot C and it is equals to 0 for given non-zero vectors A vector, B vector and C vector. Then we have to tell out of the two statements that we have given which one is true. So the statement 1 is scalar triple product of A minus B, B minus C, C minus A is 0 and statement 2 says that whether the scalar triple product of A vector, B vector, C vector is 0. So, hello everyone. Question says that let R be a non-zero vector satisfying the condition that R dot A vector is equals to R dot B is equals to R dot C is equals to 0 for given non-zero vectors A, B and C. Then we have to tell that statement 1, that is the scalar triple product of vector A minus B, B minus C, C minus A is 0. Is it true? Or the statement 2, that is scalar triple product of A, B, C vector is equals to 0. This is true. So we have given that R dot A is equals to R dot B is equals to R dot C, which is equals to 0. Now, the vector R is having a dot product with A, which is equals to 0. And similarly, R is having a dot product with B vector, which is also 0, and with C, it is also 0. So, if we consider R dot A vector equals to 0, this means that dot product is 0 if and only if this happens, if and only if R is perpendicular to A vector. This is we know by dot product, and similarly for R dot B, which is also 0, this happens only if and only if R is perpendicular to B, and similarly R dot C is equals to 0 means R vector is perpendicular to the vector C. Now we can see that R vector is perpendicular to A, B and C, all the three vectors. That means this will be possible if and only if, this will be possible if and only if A vector, B vector and C vector are all lying on the same plane, are on the same plane. If they are lying on a same plane, then any vector which is perpendicular to A, that will be perpendicular to B and similarly to C. So we can say that this happens if and only if A, B, C are on the same plane, and this means A, B and C vectors are coplanar because they are lying on the same plane. Now what we mean by coplanar vectors? If three vectors are coplanar, then their scalar triple product, that is A, B, C box, which is given as A dot B cross C. We know for a scalar triple product for vectors that are collinear, this is 0. So statement 2, which says scalar triple product of A, B, C is 0 is correct. Now we will look to the statement number 1, which says that this scalar triple product of A minus B, B minus C, C minus A should be 0. So we have A minus B, B minus C, C minus A. We have to show that whether it is 0 or not. Now, if we consider two vectors, let's say this is the vector A and this is the vector B. This is A vector and this is B vector, and we know they are lying on a same plane. Then A minus B vector can be drawn by taking B in the negative direction, so in the same magnitude. So we know this vector will correspond to the vector minus b. This will be minus b vector having same magnitude as b vector, but in the opposite direction. Now, if we add a vector and minus b vector, then by parallelogram rule, this will be the vector that will be diagonal of a parallelogram if we join this here. So this will be by using parallelogram rule, and we know this will be a plus minus b. This is a minus b. So we can say that a minus b will again lie on the plane that in which a and b is lying. So similarly, b minus c will lie on the same plane where b and c lie, and c minus a will also lie on the plane where c and a lies. That means we can say that a minus b, b minus c and c minus a lies on the same plane where a, b and c lies, and thus their scalar triple product, that is a minus b, this is a minus b dot product with b minus c cross c minus a. Scalar triple product of these three vectors will also be 0. So both the statements that we have given, that is statement 1 and statement 2, are correct. Thank you.
क्लास 6 से 12 से लेके नीट, IIT, JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।